I'm Chris Monarch. Today I'll be presenting on Django SQL injection security. And as an introduction, SQL injection is constantly one of the top 10 application vulnerabilities according to WASP, the Open Web Application Security Project. As you can see, in 2017, it was ranked #1. It was #1 for many, many years. Now it's dropped down to #3, but it's still very critical. There's a high incidence of SQL injections being exploited in the wild, as well as being found through defense in depth during software development practices. And this is a highly critical vulnerability, not only because of its prevalence, but also because the fact that it gives access to the database, which contains the most safeguarded data for many web applications and applications within corporations. SQL injection really comes down to three different types of injection attacks in the taxonomy. Error, blind, which in the blind category has Boolean and time. The error is basically when a web application is still in debug mode, or it has errors coming back to the user, so that you can intentionally do something that causes an error on a search page, and as a result get information about the database table, the query being used, and other things that could help you to attack the database system. Blind, Boolean, and timed are two different ways when you're not getting results back, but in order to test if something's working. So in the case of a Boolean, you may do a search term, which we're going to demonstrate here shortly, where it's always true, like 1 = 1, and that'll return everything rather than just a specific search term that you put in, so then you can see it's vulnerable to injection and begin to enumerate from there. And also the timed is where you put a sleep mode in, and you put a normal search term in that you would expect to return. And if it returns after the amount of time that you had put in for the sleep, then you know it's also vulnerable to injection. Defense tactics reviewed in the papers that I reviewed fall into three categories: secure coding practices, which is the object relational mapping, which what I utilized to secure my application at the end of the demonstration, and SAS, which is software application security testing, which does static code analysis to look for known vulnerabilities in coding practices, such as putting variables into quotes for your SQL injections. Network defenses, now typically firewalls traditionally weren't able to detect SQL injection, but now with the next generation firewalls and web application firewalls, they do deep packet inspections, which look for basically matches in queries in the body or headers of the information coming through that are SQL injections. So things like that deep packet inspection, being able to go and do a reg exit across there, look for those expressions. And then intrusion detection systems and intrusion prevention systems will actually look for just automated queries that are coming through from the same IP address very quickly, which is typical of SQL injection automated tools like SQL Map and others that people might use to infiltrate the system or do brute force attacks through SQL injection. And then finally, threat modeling, where it's basically modeling your application and looking for injection points where a SQL injection could occur. And this is used for many other types of attacks, but specifically the papers talked about SQL injections and where those areas of attacks would be through modeling and looking for customer interactions through that modeling. So relevance to this course, this covers topic 9, applications and their security, where we talked about secure applications, how to sanitize inputs, user inputs, and things of that nature to verify that we're building secure applications and they're not being exploited. Topic 14, database security. So this covered many topics, and one of the things I get into here is the actual passwords being hashed and encrypted, and some other encryption capabilities within the PostgreSQL database. Topic 8, SQL data manipulation language. So this is what the queries are used for, learning that SQL query language and being able to use those skills to inject queries into normal statements that are passed off to the database, and understanding the statements on the database so that you know how to inject a query and manipulate it, such as commenting out the previous query and appending additional things, whether it be using a union to add additional information to the form that's returned, or simply just appending extra statements at the end after termination and commenting. And then topic 7, data definition language. This would be taking the prior SQL injection statements a step further and actually changing the structure of the database. Typically something destructive like deleting a table would be done there. Implementation, I use the Django framework, which is a Python web application framework made to make development fast with reusable building blocks and components. I used Psycho PG2, which is the library for connecting to Postgres databases, the same one we use for some of our homework assignments in this class. I used the Postgres database version 13.4. I used Kali Linux and Hashcat, and those were Kali Linux as a penetration testing Linux operating system with a bunch of tools, Hashcat being one of them that's made for cracking passwords, specifically password hashes using brute forcing techniques, and that's what was used here. And then ORM is object relational mapping, which essentially takes all the objects in your database, creates classes out of them, and then maps those to pre-built SQL statements. And that's a technique used for secure coding so that you're not able to have SQL injections take place due to that. Here is just a little copy of my code. 2 statements. The first one being the vulnerable raw SQL, as it's called in Django, where you do a typical statement, and the vulnerability comes where you pass a variable in that's user driven in between single quotes. So this allows the user to input anything they want, including being able to put another comma in, which essentially blocks this off and ends the variable. And then an additional statement at the end, whether it be or 1 equals 1, or a union type operator that would return more than just the initial statement here, which turns out blank if we're just commenting this out, and actually returns, as I'll do in the demonstration, the schema information so that I can learn all the tables in the database, as well as then querying one of those tables to get username and passwords back. The second one is the secure methodology, and this is using the ORM, and it has the pre-built thing where it hits our part table. It's just calling the objects of the ORM, all saying it needs to bring all records back. And then what it does is it brings all records back, but it applies a filter. And this filter is the same parameter passed in earlier, but in this case, it's just simply a parameter that cannot inject any code because it's fixed based on that class model, which only accepts text of a certain length, and it'll escape any characters that would be SQL injection characters. So the results of my study were the SQL injection vulnerable code was successfully exploited, and I was able to get the admin password in hash form, crack it, and then log into the admin console, essentially having full control of the website. I tried the same tactics, enumerating the database with SQL injection once I used the ORM model, and that did fail because it was secure coding and it would not let me do the injection. So now for a quick little demo of what I did here. I have commented out the good one. We'll go back to that. So I have a search part screen here where I could do something like search for or logs or log maybe. So I could do an or log here, and it'll bring that part back. Spark part once again. I did do a like statement for the sake of this exercise. I have a direct match because I wanted to be able to demonstrate a vulnerable app here. So that will return one thing, but I have my statements here quickly so I could cut and paste. If I come back and put this statement in, this blocks off the variable, so it's not asking for spark plug or anything, but it does give in or statements that always equal to true. And if I submit that, it brings everything back from that table in the database, and it is SQL vulnerable. So that's how that works. This next statement, what it does is it comments it out, it ends it with a semicolon, and then has a new select, which pulls from the Postgres database schema table, and I'm looking for all tables, and I want to get a list of all the tables in there. And why did select 1, 2, 3, and 4 before I actually ask for the table names is because I have to match all the columns here for the union statement to actually work and to be able to append those results into the web form, because it's the code behind already has fields for each of these, and I have to name them as the fields that it's expecting for this to actually display to the screen. So here you can see it worked, it's SQL injection vulnerable still, and I get all the tables in the database, including this auth user one, which for Django developers or anybody looking at the documentation knows that's where the usernames and passwords are. And for the last statement, I will go and I will look for all the usernames and passwords in that database. And as you can see, there's 2 accounts, one named Chris, and this is the hash password, and one named admin with the hash password. So at that point, I go and I took this right here, and I was able to run it through Kali Linux. And this part here is the algorithm. This is the salt that was created along with the type of hash. And then the actual, this is actually the salt right here. And then the actual hash was right here. This whole thing gets input into the file that Hashcat reads. And there's some settings that I go into details on my report on of how that password cracking works based on the algorithm, the salt, and the Django framework, and brute forcing this. I have not included that in the demo because it did take 40 some minutes to run and actually crack this simple password. But once complete, I was able to get into the admin password here. Just got a simple password set up here. And once I came in here, I have full access to the whole site with that cracked password, where I could do many things and add users and change. So right now I will close out of there quickly, and I will go back and go to our secure code here. I'll just quickly comment all this out. So now I'm using the ORM, using these objects here. Go back to my entry screen. You see the site's working as expected. I go back to the first part of my enumeration where I look to see if it's vulnerable to SQL injection. And we see nothing's returned because it's actually searching for and looking for, the end quote or 1 = 1 comment filled in. This obviously doesn't exist in the parts database. So, this concludes my presentation, and just to summarize here, the best practices of SQL injections, according to OWASP and many other frameworks such as Django, ask for ORM to be used to avoid SQL injection vulnerabilities. That object relational mapping negates the ability to do SQL injections. But beyond that, based on research done through the papers and other sources reviewed, defense in depth should be implemented. This means not only depending on the ORM and secure coding practices, but also use a WAF or next generation firewall, use an IDS or IPS, and also do secure coding practices such as SAST and threat modeling. So thank you very much.